Alright, hey everyone. So we're going to pick up where we left off with part 2 and going through this idea of the chemical calculations using stoichiometry. So again, if you don't have the chart on the bottom, I would probably copy that into your book. It's going to be very helpful in terms of understanding how these conversions are going to go, and kind of gives you a step-by-step guide on how they look. So let's take, this video is basically going to be 3 example problems and going through and understanding how to convert from one thing into another. So this part, example 3, calculating molecules. So the question basically says how many molecules of oxygen are produced when I have 29.2 grams of water and it's decomposed by electrolysis to get this balance equation. So we've got 2 molecules of water and 2 molecules of hydrogen gas and 1 molecule of oxygen gas as products. So in this one, notice what we're starting with. Okay, we're starting in grams. And what is it asking to get into, right? How many molecules of that thing? So we're starting in grams and we're going to molecules. So if I were to take a look at this last chart that we finished off with, we're starting in grams. So I'm starting with a mass of a substance in grams. And then after that, I want to end up in molecules. Now remember, a representative particle just is a placeholder that can mean molecules, atoms, and that kind of thing. So really, I want to get here in the end. So you can see the path I have to take is going to go over and then up. Right? So I first need to multiply the mass of what I have to get into moles. I need to do a mole conversion. And then I need to get from moles into molecules. And it kind of sets up what I need to multiply by. So pause the video. See if you can set up the problem, see if you can solve for it, and come back when you're ready to go through it. Alright, so in this third part, and again, do try the question out, see if you kind of can figure out what it is. We start off and we have 29.2 grams of water. And then out of that, I've got 18.02 grams of water. I'm going to do a molar conversion here, right? I'm going from mass to moles. So here's mass of water. Now I'm going to go to moles of water. Okay, so 18.02 grams, that's what makes 1 mole. That's 2 hydrogen atoms plus an oxygen atom. Okay, 1 mole of water. Then once I'm in moles of water, that's where I need the mole conversion. Okay, mole conversion. And then I can see from the equation that I'm going to have 2 moles of H2O, right? I want to get from moles of water, and I want to get into O2. And I've only got 1 mole of O2. So 2 moles of H2O, it's whatever I'm given, right? That's what I want to cancel, 2 moles of H2O. So basically these can cancel out. And I've got 1 mole of O2 on the top. Now that I'm in moles of O2, now I want to go to the next part, and that next part is being able to convert to representative particles. So mass of H2O to moles of H2O, to do the mole conversion, and then to get molecules of O2. Now, I have 1 mole of O2, let's hear. So I know that in 1 mole of anything, in this case O2, we have Avogadro's number, 6.02 times 10 to the 23rd molecules of that thing. Okay, in this case 6.02 molecules of O2. So I can see from this equation that my grams of H2O are going to cancel, my moles of H2O are going to cancel, moles of O2 are going to cancel, all top and bottom, and then really I've got 29.2 multiplied by 6.02 times 10 to the 23rd by Avogadro's number. I'm going to get an answer, then I'm going to have to divide that by 18.02, and then I'm going to have to divide that by 2, right? Because I've got certain values that are still left, right? I'm looking for numerical numbers that I need to multiply or divide. So if I were to multiply all those correctly, at the end of the day, I should get 4.88 times 10 to the 23rd molecules of O2. Okay, so again, try it in your calculator. Make sure that you can get that to work out for you, and ask any questions if you're not sure. Okay, so that's my next part. So our next example, this one is a volume to volume calculation. Okay, so here we're saying that we start off with 34 liters of oxygen and it's reacting with an excess of nitrogen monoxide. Okay, so again, I would jot down the question. You've got the balanced chemical equation that's there, and we're going from a volume of oxygen, and it wants to know how many liters of nitrogen dioxide do I have. Okay, so I would go back to that chart. I would take a look to see how to go from volume to, and then how to get to volume at the end. Pause the video, try the question, and come back when you're ready. Alright, so let's take a peek on how to do this. So, with this one, we're going to start off. I'm going to keep that equation handy so I can reference it. We started off with 34 liters of O2. Right, I started off with a volume, 34 liters of O2. So I've got a volume of O2. Now, I need to get out of liters and I need to get into moles. Right, so I want to get to moles of O2. Well, we can get to moles of O2 because we know that there are 22.4 liters of anything of O2 per 1 mole of O2, as long as it's under standard temperature and pressure, which all these questions will be. Once I'm into moles of O2, that's where I need that mole conversion to come in. Okay, so that mole conversion, I need to get from moles of O2 into NO2, into nitrogen dioxide. So we can see that I have 1 mole of O2 here, but 2 moles of nitrogen dioxide here. So 1 mole of O2 gives me 2 moles of NO2. That's going to bring me into moles of NO2, and then from there, once I'm in moles of NO2, now I need to get to volume of NO2, because that's what the question is asking to get to volume. So, in order to get from moles of NO2 into volume of NO2, that's where we know that 1 mole of anything, 1 mole of NO2, and it's going to give me 22.4 liters of NO2. And so, the reason why these are flipped, if you look in the second part, okay, if you look down here, it's written as 1 mole over 22.4 liters, but if you look here, it's now written as 22.4 liters over 1 mole. So remember that the ratios can be flipped, and the reason why they're flipped is because I need things to cancel out, right? So liters of O2 are going to cancel here and here. Moles of O2 are going to cancel here and here. That's the reason why it's written that way to start with. Now I'm in moles of NO2, so I'm going to need moles of NO2 on the bottom so they can cancel out. The only unit left is liters of NO2. So when I multiply all these together, a funny thing actually happens out of this. I don't know if you noticed kind of right away, but you'd have 34 times 2 times 22.4 divided by 22.4. So I can actually reduce this before I even multiply, because 22.4 and 22.4 are going to cancel each other out. So really it's just 34 times 2, and that's just going to give me 68 liters of NO2. So that's an example of a volume to volume comparison. Okay, going from one to the next. Okay, example 5, finding the volume of a gas. So it says assuming standard temperature and pressure. Now it's asking, or it's kind of saying how many milliliters, okay, of oxygen are needed to produce 20.4 milliliters of SO3 according to this balanced chemical equation. Notice it's just giving you milliliters. It's just expanding that step one part further. So again, pause the video, give the question a try, see how you make out with it, and come back when you're ready to go over. Alright, so let's take a look at it. So again, I'm going to leave this up here so I can see the equation. I'm going to start off and it tells me that we have 20.4 milliliters of SO3. That's our starting point. 20.4 milliliters of SO3. I need to get from milliliters to liters, right? That's my first part. So milliliters, we know that there's 1,000 milliliters. Notice I put milliliters on the bottom so it can cancel out. There's 1,000 milliliters in 1 liter. And the SO3 is just there to keep my compound knowledgeable, so I know what it is. 20.4, I've converted milliliters into liters. Now that I've got milliliters into liters, my next step after that is going to be to convert liters of SO3 into moles of SO3. Okay, so once I want to get into moles, then I know that 22.4 liters of SO3 is going to make 1 mole of SO3. Okay, that brings me into moles of SO3. Now I need that mole conversion to happen. Okay, so I need to get from moles of SO3 into moles of O2. So moles of SO3 into moles of O2. So I have moles of SO3 already. So I know that 2 moles are going to go on the bottom. So 2 moles of SO3 on the bottom is the same thing as 1 mole of O2. That's my relationship. That's my ratio between them. Okay, my mole conversion. Now that I'm in moles of O2, now I need to get to liters of O2. So now we have that same thing set up as before. I know that in 1 mole of O2, I'm going to have 22.4 liters of O2. And then I just need to get from liters back to milliliters because the question is saying how many milliliters of O2 do I have. So in 1 liter of O2, we have 1,000 milliliters of O2. So I know that liters are going to cancel. And if I kind of look at my whole step from left to right here, milliliters of SO3 cancel top and bottom. Liters of SO3 cancel top and bottom. Moles of SO3 cancel top and bottom. And then I can kind of keep going here to make sure that I've set this up right, because I should have the same thing on the top followed by the same thing on the bottom. Now, before we were able to cancel out 22.4. If I take a look at this, I can do that again here. 22.4, 22.4. But the nice part is that I can also do the 1,000 as well because it was a set ratio. So really, I need 22.4, and then there's a whole bunch of 1s here, except for this 2 right there. So 20.4 divided by 2 gives me 10.2 milliliters of O2. That's how many milliliters I would need to convert in order to convert it back and forth. So that sets up all of the different problems, okay, or examples of the different problems. Really, they just reference this chart. So again, if you were able to have that chart, you should be okay with moving through to the next set. And with that, you're able to start the next couple of assignments. So if you have any questions, please let me know, and good luck.